So in this lab, we'll be completing detect labels, spaces, and landmarks in images with Cloud Vision API. So let me give you an overview of what this lab is about. So Cloud Vision is basically a Google service. So Google has this machine learning models that are capable of detecting features in images. They're able to classify images, put labels on them. So we'll be utilizing these machine learning models for our service, like whatever product we are building. So let's say we are building a product that can say whether a person is happy or not by looking at that image, like the image of the person. So if we have to build everything from scratch, we not only have to build our web application, but we also need to build our machine learning model, and that can be expensive because to train a machine learning model, you need data. So this is a very, you can say, time consuming as well as a complex process. So Google has already created these machine learning models. All of these are pre-trained. What we need to do is we just need to upload an image to Google Vision API, and the model will basically analyze that image, and this API will send us a response back from the model. So it simplifies a lot of things, right? We do not need to train any model. We do not need to learn any machine learning. We just need to send requests to this API, and then it will get the response back. So how cool is that? So this is what this lab is all about, actually. So before continuing with this lab, let's get familiar with some of the terminologies that we'll be using. I think you might not be familiar with it. So an API. So what is an API? API basically stands for an application programming interface. So suppose you have two programs and you want to share data between them, or basically suppose you need some data from the second program. The first program needs some data from the second program. So how are we going to share data among them? So uh, this problem can be solved by using an API. So what happens is basically the API is a service that is being run. So you put a request to that API, send a request to that API. It can requests are of many types. First of all, it can be GET request, it can be POST request. You can look about it in detail when you read about APIs. So when you put a request to the API will then basically request your second program for the data, and the second program will give that data to the API, and then API will send a response back to you. So that is how an API works. Now, instead of second program, it could be a database. So you can get data from a database using an API. Instead of a database, it could be a machine learning model. So basically, you send some data to the API. The API will give that data, or basically put that data, feed that data into the model. The model will give you some response, and then the API will send you back that response. So basically, the API acts as a middleman between uh, the end user that wants to use the service and the actual, the service, right? So that is what an API does. So next, let's talk about buckets. So buckets are basically a service that Google Cloud provides to store data. Okay, we can store any form of data in a bucket. Uh, it can be images, songs, movies, anything. Okay, anything that you want can be stored in a bucket. Now, buckets are very powerful because it allows you to basically have fine-grained control over who has access to those, uh, you know, assets or data. So you can put permissions on it, like only this person is able to read this image, only this person is able to write on this file. So yeah, you can do a lot of things with these buckets, and we'll be using buckets in this lab. Next up, uh, we have curl. So curl is basically a command line tool that helps us to make requests to an API, right? Actually, it does much more than that, but for this level, we can say that suppose we have an API that is being run somewhere else, and we want to basically make requests to the API. So for that, we use this curl CLI tool. We can basically write a request and send that request to that API using curl. So now that we are done with the terminologies, let me give you a brief walkthrough of what we are going to do in this lab. So I recommend everyone to first, carefully read whatever is here. I'm going to skip the main part, that is creating an API key. So we are going to use the Vision API, right? Basically, to use the Vision API, we need to create an API key from the Google Cloud Console. Without the API key, we will not be able to make requests to the API, right? So first, we are going to create an API key, and next, we are going to upload an image to Cloud Storage Bucket. So first of all, we need to create a Cloud Storage Bucket and then upload this image onto there. Next, basically, we need to create a request. So remember the image that we uploaded to the bucket, before that. So this we need to put that image URI here, and we need to create this request object in a file called request.json, basically, and then we need to use curl to hit this endpoint and with this request.json file that we created above, right? So basically, we are hitting this Vision API endpoint with our request, and the Vision API will give us a response back. And basically, it's going to do label detection. That is, it's going to find if it's going to basically label the image, right? So you can see there is sugar in it, and it's a dish, it's pastry, it's food, right? I'm talking about this image. Okay, the image of a donut. So once you have done that, Vision API is also able to do reverse image search on an image by using web detection. So suppose you have an image and you need to do a reverse image search. I am pretty sure you already know what a reverse image search is. Basically, you find similar images with that image. So initially we did label detection, right? In the previous request, we are going to do web detection right now. And we make the same request, but this time our request is different, right? We are doing a web detection instead of a label detection. So the response is also going to be different. So yeah, that is the response. And next is face detection. So we have this image. We are going to upload this image to Google Cloud Bucket the same way we uploaded the donut file or donut image. And we are going to make a request with this file, this image now. And the Vision API is going to do face detection and landmark detection on this image, and it's going to give us a response back. Now in task 7, we are going to do landmark annotation, and this is exactly similar as the previous task that we have done. We download this image, we upload this image to Google Cloud Bucket, and then we make a request to the Vision API, and the Vision API will give us a response back. So that is what we have been doing in all the tasks, right? So yeah, let's begin this lab then. So click on Start Lab. I'm going to open it up in an incognito window so that my personal account does not get messed up. So yeah, let's click on next. Copy the password, put it here. And first, we need to create an API key. Let's go to task 1. Understand. I agree. So to create an API key, you need to go to the navigation menu, APIs and services, and credentials. So put navigation menu, APIs and services, credentials, create credential, and API key. And I'm going to copy this API key and save it here in Notepad. I'm going to use it later on. I'm going to close it. So once you have created the API key, click on check my progress and it should show green in this way. Uh, yeah, so apart from that, you also need to export your API key. By export, I mean basically you need to create a variable called API underscore key, which will store the value of your API key. So let's do that as well. And go to Cloud Console, click on this button here, activate Cloud Shell. Okay, so you should see this dialog box in Cloud Shell. Click on continue. So as you can see, our Cloud Shell is ready. Here, copy this command, paste it as it is, and remove everything that was after the equal sign. And you need to paste your API key that you copied earlier. So with this, you basically you have a variable called API underscore key, which value is your API key, right? So we'll be using this variable when we make the request. I'll show you when. So once that is done, the next step is basically to create a bucket and upload an image to the bucket. So again, head to the navigation menu, go to cloud storage and buckets. Keep in mind, do not close this uh, Cloud Shell window, because if you close, all of the environment variables that you have exported will be gone and you have to basically export it again. So for the timing, I'm just minimizing it and I'm going to click on create. Now for the name, I think they have given us a name here in this way. I'm going to copy it, and they have also told us what options that we need to choose here. So I'm going to click on continue. Uh, they have not told us which location type we have to choose, so I'm going to leave it on default. This also I'm going to leave it on default. Yeah, and they did mention that I have to select fine grain and I have to uncheck enforce public access prevention on this topic. So I'm going to uncheck enforce public access prevention, and I'm going to select fine grain, click on continue, and the rest can be left as default. So our bucket is created. Next up, so we need to upload this image in our bucket. So first we have to save it, and we need to save it as donuts.png exactly. So donuts.png. After saving it, go to your bucket, upload files, and upload this donuts.png file. Once you have uploaded, basically you need to change the permission, like who can see this image. So you need to change it to public, like anyone can view this image. All users means everyone, and they can view this image. Like they are the reader, they cannot delete this image or modify this image. Right? So click on the three dots, edit access, create an entry, and it should be public, and it should be all users and reader. Okay, and save it. After that, you need to click on check my progress, and yeah, that is done. Now, actually, we have to make a request using this image. But what I like to do is, let's go to web detection, or rather, yeah, let's go to face detection and download this image and upload it as well. So there are four images, I think, in this lab, and basically we need to upload those four images to Google Cloud Bucket, and our lab is done. Okay, the request part is just for your demonstration. They do not contribute any pointers to the lab. I will show you what we have to do to make the request, but let's just first complete the lab first, right? So I'm going to save this image, and it should be saved as selfie.png. The exact same thing. Save it as selfie.png, and then there will be this image which I need to save it as city.png. city.png, and yeah, I don't think there are any more images. Okay, so go to Cloud Pocket, upload the files, that is the selfie.png and city.png, and we need to change their access to internet as well. So edit access, add entry, public, all users and reader, save it, and edit access, add entry, public, and all users and reader. Like all of these three are now accessible through the internet. And what we can do is, yeah, we have uploaded this image, the selfie.png, and we have made it public, so we can click on this check assessment. And we have also uploaded this landmark, so we can click on check assessment. The lab is done now. Okay, there is no more check assessment boxes. So the lab is done. Now let's make the request. Okay, you can click on end lab and it you will have a green tick mark, not an issue. But from now, what you are going to learn is basically additional add-on. Okay, it's going to help you in future, obviously when you are making projects. But for now, the lab is done. So we'll be creating the request in a request.json file. So let's do it. Create a, okay, so many of you might not know what Nano is. So Nano is a command line text editor that allows you to edit files. So what we can do is nano request.json. We will create a .json file and we'll be able to edit. Now copy this thing here and paste it using Control V. Now replace whatever is in here. Use the arrow keys to navigate if your mouse is not working. So you need to replace bucket name with your bucket name, whatever the name you entered there. So go to navigation, storage and buckets. Click on this bucket, copy the name and paste it here. And once this is done, you need to save it. So in Nano, if you want to save this file, you need to click on Control O, and it's going to ask file name to write, request.json. Just click on enter, and it's going to say wrote 17 lines. Next, to exit this editor, you need to press Control X. So this caret character actually means control. So click on Control X, and you will exit. Uh, okay. So if you want to see what is in your request.json file, you can do cat request.json, and as you can see, this is here. Next, we are going to make the request using Perl CLI. So go down, copy this, and paste it. And I'm going to explain what every flag here is. S means you want the output to be silent. That is, you not want too many information. The logging information or any information that the curl will output. Hyphen X post means we are going to make a post request, right? So there are many types of requests like get, put, hash, delete. So post is one type of request. Hyphen H is you're basically adding this header to your request. So content type application slash JSON. Now, what is the request data? The request data is to be read from this request.json file. This is what it means. Okay. Now, where is our API? Our API is in this endpoint. Okay. Our API is in this endpoint, and this thing that you see here, dollar sign curly braces API key. Remember, we exported our API key variable before API underscore key using export. So this will basically replace with that value. Okay, so this variable will replace this with our API key variable, API key value that we have created from Google Cloud. So this is what this command does. Click on enter, and it's going to give us a response back. Now, let me tell you what this response is all about. Mid. So what is mid? Mid is an ID. It's kind of it stands for machine ID. So you know Google is a search engine, right? So what happens is Google has lots of data, and when you have lots of data, you need a way of identifying uh, what data to find when someone searches for it. So what Google has created is something called as a knowledge graph. So you can look more about it actually. Knowledge graph here. It's a very interesting thing. So Google has this graph of all the data that is on the internet that you can search through Google, and it basically creates relations among data. So suppose, let's say you search Mahatma Gandhi. So when you search Mahatma Gandhi, you can see like in the related topics, you will find, let's say, independence, India. You'll find, related freedom fighters. You'll find things related to Mahatma Gandhi, right? So how does Google know what are the things related to Mahatma Gandhi? It has a graph, right, with all the nodes basically surrounding Mahatma Gandhi related with the related topics. So this image that you just uploaded, so Google has a knowledge graph for it, and basically it's giving you that ID, right? Or rather, actually, it's giving you the ID for this label actually for food. Okay, not the image that you just uploaded. And the score is basically how certain that this model is that it's a food. So it's 98% sure that it's a food. It's 91% sure that it's a baked meal. I hope I spelled it correctly. It's 89% sure that it's ingredient, powdered sugar 85%. So you get the point, right? So this is the response that you got from the API. Now, web detection. So the same image, earlier we did label detection, right? So let's open our request.json file. So we did label detection last time. This time let's do web detection. So to save it, Control O, enter, and Control X to exit. So we are going to make the same request. You can use the up arrow to go through the previous commands that you have entered. And you can see like it has given us a different response this time, like best guess label, powder sugar. If you go on this URL, it gives you some other food items, right? If you go on this, it's not giving us anything. So yeah, it somewhat did of a reverse image search on that image. So you can see these are like food items related to that image that we have uploaded. So that is what we have got. Now, this why am I showing you all of these things? Because see, this by looking at this, it might seem completely useless. Like, what am I going to do with this API? But imagine if you have a web application for reverse image searching, right? Or for like let's say a recipe website where you basically upload a photo and then you get the recipe of creating that whatever is in that. If it's food, you'll get a recipe of creating that food. So how cool is that? You can do a lot of things with this API. Next, face detection. Yeah, this is very useful as well. So remember, we have uploaded our selfie.png file. So we are going to change our request.json again. This time in features, we are going to have these two features. So in our type, we need to change it to basically face detection. And let's remove this max results and landmark detection. And instead of donuts.png, we have to replace it with selfie.png. Save it and exit. And we're going to make the same request. So you can see we got a response back. Now you can see things like joy likelihood, very likely. So in this image, basically, it's probably detecting emotions, right? Sorrow likelihood, very unlikely. Anger likelihood, very unlikely. So you get the point. You can do a lot of things with this API, right? It's also giving us positions. I will be showing you how to utilize this data for your application later on in this video. So let me show you the third use case as well. That is landmark annotation. So let's edit our request again. This time, instead of selfie, we are going to change it with city.png. And we do not need face detection here because we do not have any faces in this image. So I'm going to remove it. So save it just like usual. Send the same request. This time you get a different data, right? Like description, red square. So let me see what. Okay, let me see what red square is actually. It's probably this place. I'm not sure. Okay. Uh, so yeah, you get some response. And I think this is the end of the lab. Okay, okay. There is one more thing, and this is, I think, very interesting. Object detection. So we have actually completed a lab, and this object detection is it does not we do not have to complete it in order to complete the lab. It's just you can say somewhat of an add-on, and I'll be showing you what can be done in object detection. But you can end the lab right now. Okay, you could have ended the lab once you've uploaded the four images, three images. It would have been an issue. So once you have ended the lab, you go back and you make sure that there is a green tick mark here. So you can see there's a green tick mark. So that means this lab is completed. So let me show you the last task. The lab, I completed it. So this is an add-on as I already said. So object localization. This is this image of a bicycle. So open it. As you can see now, how can you predict a bicycle? Obviously, you can. You are a human. But how can a machine do it? Now, there are machine learning models trained to do just that. Okay, and we have not created a machine learning model. Google has already created it. We are just going to upload this image to the API, through the API, not to the API. And the API is going to feed this image to the model. The model is going to send us the coordinates of where it thinks the bicycle is, and then it's going to give it back to us, right? And then we can basically, using those coordinates, we can identify the bicycle. And I'm going to show you how. So, okay. So just like previously I've showed, this is a request object. This is the image URI that I have opened here. The type of feature is object localization. And then similarly, you need to make a request to the API using CURD. You will get a response back in this manner, right? So let me show you how to utilize this. So for the bicycle, You can see these are the coordinates that uh, the model has returned, and these are the coordinates the model thinks where the bicycle is located. So let's see if it's correct. Let's see if the model is correct. Okay, so I'm going to, within this tab, I'm going to open my console. What I'm going to do is, this is the image, right? I'm going to edit as HTML. I'm going to remove all styles from it, and I'm going to add an ID of image. So all the styles are gone, the alignment now. Next, I'm going to go to sources and here click on snippets. Okay, if the snippet is not available, you click on this double arrow and the snippet will appear here. So I have this JavaScript file, right? So what it does, it basically gets the image from the document. So get element by ID. So whatever element having this ID of image, this piece of line is going to get that. We are going to create a canvas, and we're going to set the canvas's width to the image width and image height, and then we are going to basically overlay that canvas on top of our image, right? So position absolute, and then left and top is image dot offset left and image dot offset top. That is all like HTML stuff. The interesting stuff appears here. So all these coordinates, I got it from here. So you can see the x is 0.312, y is 0.6616, and the four coordinates. All the four coordinates I'm putting it in these two arrays, x coordinates and y coordinates. Next, I'm going to create a context or CTX and basically set the stroke color to green. These are pretty HTML stuff. Okay, so you can, if you do not know about this, you can Google them up. You will know what it is. So we are going to start from this coordinate, x coordinate dot 0 into canvas dot width. Now, why am I doing canvas dot width? Why am I multiplying this x coordinate with canvas dot width? Because it's a normalized vertices. Okay, so these are not the actual vertices, like, because this image can be resized to any shape, right? So it's currently 916 to 640, but I can resize it in any shape, right? So it's not returning us what position is position it is in pixel. It's actually returning us what the position is in pixel divided by the width of the image. So when we multiply this value with the actual canvas width or the image width, then we get the original position. And basically this is how it works. Okay, it never returns us the hard-coded pixels of where the image is located, because then if we resize this image, all the coordinates will be messed up. So basically we need to multiply it by canvas width, the x coordinate, and we need to multiply the y coordinate by canvas height, and we are going to iterate through all the vertices, and we are going to map it, right? So let's run it. We have to press Control Enter, or you can click on this button here. So once you have done it, you can see a green line around this bicycle. So that means the coordinates were right. Like, yeah, the API detected where the bicycle was, gave us the correct coordinate, and we are able to detect it. Now, just imagine the applications that you can build using this API, right? Not just bicycle, you can do a lot of cool stuff with it. It's up to your imagination. Okay, so did you know any machine learning for it? You might have known, but yeah, I didn't know any machine learning, but I'm able to create an application that utilizes machine learning. How cool is that? So yeah, this is one thing that I would like showing to you guys. So I hope whatever you learned in this lab, you utilize in creating good projects, right? So yeah, let's end it here.